Hello, all the students. So you can write hi in the live chat to say hi to Madam. So for tonight class, basically I will go through the first I will do the summary for the alkene, and then I will go through the hydrations and also hydrohalogenation reactions mechanism. Okay, so without further ado, so shall we start the class? Okay, so the focus for tonight class will be the two reactions mechanism, the hydrohalogenations and also hydrations. Okay, but before I go through the two reactions mechanism, so shall we revise first the alkene? So for alkene, so you have seen how to prepare alkene. So there are two ways for us to prepare alkene, and basically the type of reaction to prepare alkene is, so the type of reactions involved is elimination. So the type of reactions involved to prepare alkene is elimination. So basically, if it is from the alcohol to eliminate to get this alkene, so how do we do the reaction? So for example, if we have alcohol, okay, so this is the alkene that we are going to get. So how to draw the alcohol? So I have gone through this in the class. So kalau alcohol, then remember alcohol is saturated. So all are single bond. So how to draw the alcohol? So we can have the H or OH at either side, doesn't matter. And then remember, from the alcohol, how do we prepare the alkene? It is through dehydrations of alcohol. Remember, from the alcohol, we eliminate the OH and also the H. So when we eliminate the OH and the H, so we get the alkene. Okay, we get the alkene. So, and then still remember what is the reagent that we need in order to do the dehydrations of alcohol. So basically we need concentrated sulfuric acid and then heating in order to remove OH and the H from the alcohol to give us alkene. So this is the first way to prepare your alkene. So the second way to prepare alkene is through haloalkane or alkyl halide. So if this is the alkene that is being given to us, how do we draw the haloalkane? So it's still the same. So rangka dia masih sama. So the rangka dia masih sama. But then to draw back the haloalkane or alkyl halide, we just need to add in the hydrogen and also the halogen. The hydrogen and also the halogen. Remember, your haloalkane is saturated. Okay, so semua single bond. So you can put in your H or Cl at either side. Doesn't matter. Okay, so from your haloalkane, how do you get this alkene? It is through removal of hydrogen and also the halogen. Therefore, this way of preparing your alkene is called dehydro, sebab remove hydrogen, halogenation, because you remove the halogen as well from the haloalkane. So from the haloalkane, we are removing HCl. So HCl is an acid. So to remove it, we need a base. Okay, we need a base. Okay, so example of the base that we can use is KOH. And then the KOH is solid, so we need a solvent. So the solvent example, ethanol. And then for this reaction, kita kena reflux. Means that you heat it at the boiling point. So this is the two ways to prepare your alkene. And then remember to determine whether major or minor products is being formed. So it is determined by the Sazeph's rules. Remember, Sazeph's rule stated that in the eliminations reaction, the alkene that produced will be the major product if the alkene is more stable. And then the more stable alkene is more highly substituted alkene. Okay? So Sazeph's rule to determine major products. So this is to prepare alkene. And then in the Wednesday class, we have looked at the reactions of alkene. So for reactions of alkene, so akan berlaku kat mana? The carbon-carbon double bond. Why berlaku kat carbon-carbon double bond? Because carbon-carbon double bond is electron rich. So who will attack the carbon-carbon double bond? The electrophile. Okay, so therefore, alkene undergo electrophilic additions type of reaction. Okay, so it depends on upper electrophile yang digunakan untuk mengerang the carbon-carbon double bond. Okay, so if you have hydrogen with the presence of catalysts such as platinum, then again, the carbon-carbon double bond will become single bond. Okay, so the rest, you tidak kacau, so it will not change. So, saling je. Only the carbon-carbon double bond will become the single bond, and then your electrophile, hydrogen, okay, so the hydrogen atom will be added at each side. So this one, your electrophile is hydrogen. Therefore, this reaction, the name is hydrogenation. Okay, and we also have seen the halogenation. So for halogenation, you have seen in inert solvent. So inert solvent won't affect the product. Okay, the carbon-carbon double bond still undergo addition type of reaction. Addition type of reaction. So bermaksud the carbon-carbon double bond will become the single bond. Will become the single bond. Yang lain tidak ubah, kita saling je. Okay, and the electrophile now is the bromine. So each bromine atom will be added at each side of the carbon-carbon double bond. Okay, so now the electrophile is bromine. Therefore, this reaction is called halogenation or bromination. And the solvent that we use is inert solvent. So therefore, in inert solvent or solution. Okay, and bromination can also occur at so the solvent, not necessarily inert solvent, we can also use water. We can also use water. Again, it is still additions type of reaction. So kalau additions type of reaction, the carbon-carbon double bond will become single bond. Yang lain tidak kacau. So kita saling sahaja. The molecule can be as big as it can. Tapi reaction hanya berlaku kat the functional group carbon-carbon double bond. And this is electrophilic addition. So double bond menjadi single bond. So according to Markovnikov's rule, so Markovnikov's kata apa? The halogen atom will add to the side which has more hydrogen. So this first carbon, we have 2 hydrogen. Second carbon of the double bond, the other hydrogen. So which side has more carbon? So the first carbon here, So your halogen atom, so atom means satu, will masuk this carbon. So bromine will go into here. So after bromine atom go into the first carbon, actually you will get a positive charge like this. Okay, and then this is water. So water as a solvent, it will affect the product. So since CD positive, so what need to go in? It must be the partially negative charge side of water will go in to give you the product. So for this one, we are still doing halogenation. Our electrophile is still halogen. So halogenation or bromination, but now the solvent is water. Okay, so beside halogenation, so the other day we also see the hydrohalogenation. So for example, HBr. So again, this is electrophilic addition. So electrophilic addition. So bermaksud your carbon-carbon double bond will become single bond. Yang lain not affected, we just need to copy. And then we have seen this. Also, the product form. Okay, so how to form the product? Again, it will form according to Markovnikov's rule. So Markovnikov's kata apa? Again, when we add HX into carbon-carbon double bond, the hydrogen will go to the side of the carbon-carbon double bond yang mempunyai lebih banyak hydrogen. So the first carbon here has more hydrogen. Therefore, hydrogen will come here. The hydrogen of the HBr will come to the first carbon, and the Br will go to the second carbon. So this is according to Markovnikov's rules. Okay, and then so the name of this reaction is called hydrohalogenation. Okay, and then hydrohalogenation, the HBr with HBr can also occur with the presence of peroxide. And I told you already, so the peroxide, so we know that the peroxide, the peroxide, it is still addition, tapi it will be the anti-Markovnikov. So it will be anti-Markovnikov. Okay, so kalau nampak peroxide, so not Markovnikov, but will be anti-Markovnikov. So Markovnikov kata apa? The hydrogen kena pergi the carbon that has more hydrogen. So anti-Markovnikov will be the opposite. The hydrogen need to go to the carbon yang kurang hydrogen. So it need to go to the second carbon. But it is still addition type of reaction. Di mana carbon double bond become single bond. So masih lagi become single bond. But now this is anti-Markovnikov sebab ada peroxide. So the hydrogen of HBr need to go to the second carbon yang mempunyai kurang hydrogen. And the Br need to go here. Okay, so this is also hydrohalogenation reaction. Tapi disebabkan oleh peroxide, it is anti-Markovnikov's rules. Okay, and then we also look at hydration. So we also look at hydration. So hydration, okay, so need to have the catalyst. So usually we say this is acidified water. Acidified water. So for this, so again, it is electrophilic addition. Electrophilic addition. So if electrophilic addition, then carbon-carbon double bond will become single bond. Yang lain tidak kacau, kita saling je. So will become single bond. So this one, again, follow Markovnikov's. Okay, mengikut Markovnikov. Okay, so Markovnikov's rules. So kalau mengikut Markovnikov, our electrophile here is water. So the hydrogen of water kena pergi carbon yang mempunyai lebih banyak hydrogen. So this carbon. And then the OH must come here. So this is hydration. So this is to revise what you learned in Wednesday night. Okay, so I just revised quickly. So, and tonight, okay, so, and of course, the other day we also look at the Bayes test and also the oxidative cleavage. But tonight, I'm not going to focus on that because tonight our focus is to look at the hydrohalogenation mechanism and also hydration mechanism. Must remember for both the product, it is according to the Markovnikov's rule to predict the products. Okay? So now, shall we move on to look at the mechanism for hydrohalogenation? Okay? So, write the mechanism for formations of major product. Okay? We know that yang ini adalah electrophilic. Okay, let me change the color. Okay, so this is electrophilic addition. So electrophilic addition, so bermaksud double bond akan menjadi single bond. So shall we draw the product? So yang tidak kacau, kita saling je. So the double bond will become single bond because this is electrophilic addition. So electrophilic addition, double bond will become the single bond. Okay, so and then this electrophilic addition adalah mengikut Markovnikov's rule. So apa encik Markovnikov kata? The hydrogen of the electrophile need to go to the carbon yang mempunyai more hydrogen. So the first carbon here ada 2 hydrogen. And the second carbon only have 1 hydrogen. So the first carbon ada lebih banyak hydrogen. So the hydrogen of the electrophile must go to the carbon yang mempunyai lebih banyak hydrogen, which is the first carbon here. And the Cl will go here. This is according to which rules? Markovnikov's rules. So this is the product. Okay, so this is the product. So now shall we look at the mechanism? So shall we look at the mechanism on how to get this product? So I already taught you mechanism. Kita bukan start dengan burger, kita kena start dengan the bread. Okay, so we need to start with the bread and also the egg. So what is our bread here? So our bread here is the alkene. Okay, it's the alkene. So apa kamu perlu buat in the first step? Salin dulu your alkene. So this is your alkene. So this is the bread and also the egg. Okay, so the egg. So in the first step, we want to form carbocation. We want to form carbocation. So again, involve bond breaking and bond forming. So which bond must break? And it must break heterolytically. Okay, so can you see that this bond must break? The hydrogen and also chlorine bond must break. Okay, and it must break heterolytically, but this is a polar bond. Hydrogen partially positive, chlorine partially negative. Okay, so this is a polar bond. So it need to break heterolytically. Chlorine more electronegative. So when chlorine break, so when the bond break, both electron will go to chlorine. Sebab chlorine lebih electronegative. So when the bond break heterolytically, kedua-dua elektron akan bergerak ke chlorine. And then, who will get this hydrogen? Siapa ambil hydrogen ini? So, it's the carbon-carbon double bond. Because tempat sini, electron rich, kaya dengan elektron. So, it can use the electron membentuk bond with hydrogen. Membentuk bond with hydrogen. And then, what do we get? And mana satu carbon akan dapat hydrogen ini? Again, mengikut Markovnikov's rule. Mengikut Markovnikov's rule. So this carbon ada dua hydrogen. Ini satu. Markovnikov kata the carbon yang mempunyai lebih banyak hydrogen akan dapat the hydrogen. Okay, so therefore this hydrogen will go to the first carbon. Because according to Markovnikov's rule, okay, there is a get. So kita salin je. So we know that first carbon lebih banyak hydrogen, so it will get this hydrogen. So it will get this hydrogen. So the bond is formed here. And look at this carbon, hanya ada 3 bond. 1, 2, 3. 3 bond. So means that we know that carbon 4 valence electron. Tolak 3, so tinggal 1. So means that here positive 1. Okay. And the chlorine get the 2 electron, become negative 1. So kenapa negative 1? Class, okay, you should know why negative 1. So if I draw out all the lone pairs, if I draw out all the lone pair, dekat sini, the chlorine has 1, 2, 3, 4, 5, 6, 7. So 7 minus 7, so you get 0 form the charge. Okay, but then at here, if you count, there are 8 electrons. So 7 valence electron tolak 8, so you get negative 1. Or you can see in the way that so this bond, hydrogen bagi 1, chlorine bagi 1 to form the covalent bond. Tapi selepas the bond break, the chlorine also take the hydrogen punya electron. That's why it become negative 1. So this is the first step of the reaction, forming the carbocation. And this carbocation Can you see that? Satu hydrogen, 2 alkyl group. So this is secondary carbocation ion. Okay, so this is step number 1. So possible to have rearrangement. Kita tengok kawan dia. This is primary. This is primary. So no rearrangement. Remember, rearrangement need to form more stable carbocation ion. So the neighbor are primary. So not possible to have rearrangement. So after we get the carbocation ion, then we can move on to step number 2. So step number 2, I told you already, we need to bring down the intermediate. Kita guna the intermediate. So what is the intermediate here? So this is the intermediate that we get from step 1. So we copy it into step number 2. So step number 2, nucleophilic attack on the carbocation ion. So from the step number 1, so we get this carbocation ion. And we get chloride ion. This chloride ion now is the nucleophile. It's the nucleophile, gaya dengan electron. So nucleophile. So this nucleophile will use the lone pair to form bond with the carbon. Okay, so step number 1 tadi melibatkan bond breaking. And then here bond forming. Okay, bond breaking and bond forming. In step number 2 is just the bond forming. So you get CH3, CH, CHHH, and then dua elektron ini sudah membentuk ikatan. So ikatan, so means that Cl now tinggal 3 lagi lone pairs. Like this. Okay, so this is the 2-step mechanism of hydrohalogenations to give us the product. So can you write in the chat, am I too fast? You need me to slow down? You need me to slow down, class? Am I too fast? Okay, so no one responds, so means that okay. Then I move on. So now shall we look at the example? Okay, so the example. So in this question, 3-methyl-2-pentene will react with hydrogen bromide, okay, HBr, to produce P. The question asks you to state type of reaction taken place and give the structures of P. Okay, so structures of P. So means that more than one product. Okay, so shall we have a look? So state the type of reaction. So shall we draw our 3-methyl-2-pentene first? So pentene, 5 carbon. So 5 carbon, 1, 2, 3, 4, 5. Okay, so 2-pentene. 2-pentene bermaksud carbon-carbon double bond antara carbon number 2 and number 3. 3-methyl. Okay, so this is CH3, so CH2. So ini sudah 4, ini 3, so 1 H dekat sini. Okay, ini 3. So this is our 3-methyl-2-pentene. The question say react with HBr. Nampak tak? Here our functional group carbon-carbon double bond. So kalau carbon-carbon double bond, Okay, and the reagent kita adalah HBr, so means that the type of reaction, so carbon-carbon double bond, electron rich. So electron rich, siapa akan serang dia? Electrophile, that's why it's electrophilic. And carbon-carbon double bond, you learn, will undergo what type of reaction? So addition, double bond menjadi single bond. Therefore, the type of reaction taking place here is electrophilic addition. So ask you to draw the structure of the product. So again, mengikut Markovnikov. So this electrophilic addition tak ada peroxide. So kalau tak ada peroxide, mesti mengikut Markovnikov's rule. So kalau mengikut Markovnikov's, the hydrogen of the HBr kena pergi carbon yang lebih banyak hydrogen. So can you see that the second carbon here has one hydrogen? Carbon ini tak ada. So means that the second carbon lebih banyak hydrogen. So means that selepas addition, the hydrogen of the HBr kena pergi the carbon number 2. So shall we draw the product? So again, double bond need to become single bond. Okay, so according to Markovnikov, here must be your hydrogen, okay, and then your Br must be here. Okay, so your Br must be here. Okay, so this is your B. Okay, so this is your B. So I think you get one product only. Okay, so B. Okay, so sorry, not B. This is your P. Okay, so any questions so far, class? Are you all clear? Are you all clear with this? Okay, so am I too fast? Okay, so no, then we move on to look at how to draw the mechanism, okay, to form the products. Okay, so I have done this. So the type of reaction, electrophilic addition, and the product is just now I already draw. So now shall we move on to look at how to draw the mechanism. So step number 1 is formations of carbocation. Again, we need to start with the break. So our break here is 3-methyl-2-pentene. Okay, so 3-methyl-2-pentene. React with HBr. Okay, so this is partially positive, partially negative. So again, the first step involves bond breaking and also bond forming. Okay, so hydrogen ini akan didapat oleh the second carbon here because the third carbon has 0 hydrogen, yang ini 1 hydrogen. Remember Markovnikov's rule kata apa? So the hydrogen need to go to the carbon yang mempunyai lebih banyak hydrogen to start with. Okay, so what we will get is CH3. So CH. So this carbon will get the hydrogen. So can you see the third carbon here belongs to the carbon? So 4 valence electron tolak 3, so positive 1. Okay, and the bromine, remember, so if we draw out all the lone pair, so 3 lone pair, and then after bond breaking, it becomes 4 lone pairs. Okay, it becomes 4 lone pair. Okay, and then so why is it -1? Because again, after bond breaking, dia ambil hydrogen punya electron. That's why -1. Okay, so that is step number 1. So step number 2. So remember, step number 2 is nucleophilic attack on carbocation. So in the step number 1, the carbocation that we get is, okay, I forgot. So CH2, CH3. So here is the positive charge, and then the nucleophile is the bromide ion. Okay, so the bromide ion will use the lone pair to form bond with the carbon, so to give you the product. So these 2 electron sudah membentuk ikatan ini. Okay, so already formed the bond. So means that 3 more lone pairs. Okay, so basically these are the 2 steps for hydrohalogenations. So again, hydrohalogenation, tengok after first step kita dapat carbocation. So this is tertiary carbocation. Kalau kita dapat primary or secondary carbocation, kita kena tengok the kawan kat sebelah. Okay, like this one, this is secondary. This is secondary. That's why tidak akan berlaku rearrangement. But if kawan sebelah, if this is a primary carbocation dan kawan sebelah adalah secondary, then rearrangement can occur. Kalau dia adalah secondary, kawan adalah tertiary, then rearrangements can occur. Okay, but for this one, this is tertiary carbocation already, so paling stabil dah, so rearrangement will not occur. So done copying. So if done, then we move on to the next one. So now we move on to look at hydration. So in hydration, we require acid as the catalyst, okay, for this reaction. Okay, so now shall we move on to look at the mechanism for hydration. Okay, before we move on to look at the mechanism, shall we write the products? Okay, so shall we draw the products for hydration? So again, hydration also, the product, we predict the product according to the Markovnikov's rule. We predict the products based on the Markovnikov's rule. So still remember, for Markovnikov's rule, hydrogen kena tambah ke carbon which has more hydrogen. So this is the carbon-carbon double bond. Hydrogen ini mempunyai carbon ini mempunyai 2 hydrogen. This carbon 1 hydrogen. So this carbon mempunyai lebih banyak hydrogen. Therefore, the hydrogen of the water will go to the first carbon. Okay, and the OH will go to the second carbon. So we will get so again, this is electrophilic addition. So kalau addition, double bond menjadi single bond. Double bond menjadi single bond. And according to Markovnikov rules, hydrogen of the water kena pergi carbon number 1 sebab dia mempunyai lebih banyak hydrogen. And the OH will come here. So this is one product. Another one, you will get is this. And this is the major product. So, how to get this? So, kita akan tengok. Okay, kita akan tengok. Okay, it is again due to rearrangement. It is due to rearrangement. Okay, we will see this in the mechanism. We will see this in the mechanism. Okay, so we will see this in the mechanism. After first step, after form the carbocation ion, rearrangement boleh berlaku. Rearrangement boleh berlaku to form more stable carbocation ion. Kalau dapat more stable carbocation ion, the product dari the carbocation ion yang lebih stabil will be the major products. Okay, so shall we look at the mechanism? So shall we look at the mechanism? Again, to draw the mechanism, we don't start with the burger, we start with the bread. So where is our bread? So this is our bread. So copy. You need to react with, so in hydration, yang ini kaya, carbon-carbon double bond kaya. In hydration, we have water and also H3O+. Kaya kena react dengan miskin. So between water and H3O+, siapa miskin? Water kaya sebab it has 2 lone pair. While H3O+ is poor in electron. How do we know it is poor in electron? Tengok the charge positive. So it is positively charged. Therefore, dia miskin electron. So your alkene carbon-carbon double bond need to react with H3O+, sebab miskin electron. So how to draw H3O+? Oxygen. So 1 lone pair. Okay, so this one 1, 2, 3, 4, 5. 6 valence electron minus 5, so positive 1. Okay, so now to form carbocation ion, okay, again involve bond forming and bond breaking. So again, mana tempat kaya? So your carbon-carbon double bond. So this carbon-carbon double bond will use the electron to take the hydrogen. And the bond between hydrogen and oxygen will break. Bond between hydrogen and oxygen will break heterolytically. Sebab this is a polar bond. And oxygen will get the electron sebab more electron negative. Okay, so now mana satu carbon akan dapat this hydrogen according to Markovnikov rules. According to Markovnikov rule, carbon yang mempunyai lebih banyak hydrogen akan dapat hydrogen ini. Okay, so because of that, so your intermediate you will get So the hydrogen need to go to the first carbon sebab lebih banyak hydrogen. Okay, can you see that carbon ini sekarang ada 3 bond sahaja, 4 minus 3, so become positive 1. And this is secondary carbocation. Okay, and also you get water. Okay, so look at this secondary carbocation. Tengok kawan dia carbon ini. So this is tertiary carbon. Okay, so tertiary carbon. So ada 1, 2, 3 kawan carbon. So tertiary carbon. So it is tertiary carbon. So bermaksud rearrangement boleh berlaku to form more stable carbocation. So rearrangement can occur to form more stable carbocation. Okay, so shall we draw the rearrangement? So how to draw the rearrangement? So I already taught you. So need to move what over? Need to move the hydrogen over to the carbon that carry the positive charge. So this is moving the hydrogen over. Therefore, it's called 1,2 hydride shift. Okay, so 1,2 hydride shift, and you get this. So now the positive charge is on the on this carbon. So this is tertiary carbocation. This is tertiary carbocation, which is more stable. So major product mesti dari carbocation that is more stable. That is more stable. Okay, so after we get the more stable tertiary carbocation, then because the questions want major product, so kita guna tertiary carbocation to do the next step. Okay, so to do the next step. So in the next step, so you already get your tertiary carbocation. So carbocation positive charge, so miskin. So kalau dia miskin, dia kena react with water. Dia kena react with water. Sebab water kaya. Miskin react dengan kaya elektron. So water So what happened is nucleophile attack. Nucleophile attack. So siapa nucleophile dekat sini? Nucleophile kaya elektron. So oxygen of the water kaya elektron. So guna the lone pair attack the carbon that carry the positive charge. Okay. Two-headed arrow. Okay. So what we get is CH3, CH3, CH2, CH3. So 2 electrons forming one bond, So we still have 1 lone pair and 2 hydrogen. Okay, and 2 hydrogen. So now look at this oxygen. 1, 2, 3, 4, 5. So 5 positive charge. Okay, so this is step number 2. So this is bond forming. Okay, remember step number 1 just now, bond breaking and also bond forming. In step number 2, we have bond forming. Okay, so we move on to look at step number 3. So in step number 3, okay, so after step number 2, we get something like this. We get something like this. We want to form alcohol. We want to form alcohol. We want to form alcohol. This is not yet alcohol because alcohol only OH. But here we have 2H and 1O. We just want 1H and 1O to form alcohol. So means that what we need to do is we need to remove this hydrogen. So to remove this hydrogen, kita kena break bond ini. Bond ini kena break. So again, polar bond break heterolytically. Lepas bond breaking, oxygen akan dapat the electron sebab oxygen more electronegative. So how to draw? Dari bond pergi oxygen because oxygen more electronegative. Then we need someone to take the hydrogen. We need someone to take the hydrogen. So yang ini positive charge. Can you see positive charge here? Means that missing electron. So we need someone kaya to take the H. So siapa kaya kat sini? We only have water and H3O plus to choose. Siapa kaya? Water. So means that water will coming, use the lone pair on hydrogen to form bond with the hydrogen. Okay, to form bond with the hydrogen. Then what you get is the alcohol. And also H3O plus. So I told you already just now, the H3O plus is the catalyst in this reaction. So it's the catalyst in this reaction. So in step number 1, kita gunakan dia. In step number 3, at the end of the reaction, kita hasilkan dia balik. Kita hasilkan dia balik. Okay? So, are you all clear? Am I too fast? Am I too fast, class? Am I too fast, class? Okay, so then we move on to look at the next one. Okay, so we move on to look at the next one. So again, we want to draw the, okay, good. We want to draw the mechanism to form the major product. Okay, so now shall we draw the product first? So again, yang ini adalah electrophilic addition. So electrophilic addition. So addition bermaksud carbon-carbon double bond become single bond. So means that, okay, so here it becomes single bond. Okay, so it becomes single bond. So, and then, nampak tak? And then, must remember, so this one, hydration, the product based on the Markovnikov rule. Based on the Markovnikov's rule. So, means that the hydrogen of the water kena masuk to the carbon that has more hydrogen. For these two, mempunyai bilangan hidrogen yang sama. So means that this hydrogen boleh pergi sini. Boleh pergi this carbon. Okay, so can go to this carbon. Okay, and then OH can come to this carbon. Or dia juga boleh masuk this carbon. So when masuk this carbon, sorry. Okay, let me. Okay, let me draw first. Then I will explain again. So mengikut Markovnikov's rule, hydrogen of the water kena masuk ke carbon yang lebih banyak hydrogen. But this one both the same. So dari produk pertama masuk carbon ini, so dia juga boleh masuk carbon ketiga. So the hydrogen can also go to carbon ketiga, and then you get this. Okay, so and then belum habis lagi, you will get another product. So when hydrogen masuk belah sini, when hydrogen coming here, so means that you will get a positive charge here. So kalau positive charge here, tengok the gawang ini, this is tertiary carbon, so can undergo 1,2 hydride shift. So when go to 1,2 hydride shift, OH can end up on the fourth carbon, on this carbon. Okay, so because of that, there will be another product. So sekarang hydrogen ini adalah dari ini 1,2 hydride shift pergi sebelah. And OH can come in here. So this is the major product. Why this is the major product? It is because it is formed from the more stable carbocation intermediate. Okay, the tertiary carbocation ion. Okay, so now shall we look at the mechanism on how to get these major products. So step number 1, formations of carbocation ion. We need to start with the break. So this is electron rich, okay, will react with electron poor. Okay, so untuk step ini, bond will break, and the carbon-carbon double bond, okay, bond will break, oxygen and hydrogen bond will break, and then the carbon-carbon double bond gaya electron, so it will use the electron mengambil the hydrogen. And this will give you CH3, CH, H. We want the major product. So H, CH2, CH3. So this is your secondary carbocation ion. And water. Okay, look at the neighbor. So neighbor here, tertiary. This one, secondary. Okay, so secondary, this is secondary. So not possible to go to the secondary. It will go to the tertiary. So how to form more stable carbocation ion? Again, rearrangement will occur. Here, also the same thing. 1,2 hydride shift. So to give CH3, CH2, So here, so H bring over, so CH3, CH2, CH3, so positive charge here. So this is tertiary carbocation, which is more stable. Okay, so am I too fast? Okay, so this is step number 1 plus the rearrangement to get more stable carbocation. And then step number 2, the tertiary carbocation will be attacked by water. Okay, so you also can see from here. So in the step number water, we won't get water as a byproduct. So this one will be used in the reaction in the next step. So in the next step, so water will come in to attack the carbon that carry the positive charge. Okay, form the bond. Then membentuk protonated alcohol. Okay. So, and then in the last step, so in the last step, the protonated alcohol okay, mau membentuk alcohol, so means that the to break. So apabila bond break, it will go to oxygen sebab more electronegative. Then someone need to take the hydrogen. Someone need to take the hydrogen. So overall protonated alcohol positive charge. So dia miskin electron. So kalau miskin, it need to react with water yang kaya elektron. So the water will use the lone pair of oxygen untuk ambil the hydrogen. Then you get the alcohol. And also so it will be generated at the end of the reaction. Sebab step number 1 you gunakan dia, in the last step you generate dia balik. Okay, so we have seen the two mechanisms, hydrohalogenation dengan hydration. Yeah, so step number 3 you can also call it as deprotonation. It's the same thing. Sebab D means that you remove, you eliminate. And here you eliminate the hydrogen from the protonated, it's actually hydrogen ion from the protonated alcohol. So shall we look at the PSPM question. So this is inside your mastery practice book. So PSPM question number 2. Okay, PSPM question number 2. So this one is to revise a bit on apa yang kita belajar for hydrocarbon chapter. So hydrocarbon chapter, you belajar alkane and alkene. So alkane only undergo one type of reaction, that is free radical substitution. And alkene undergo two types, electrophilic addition and also oxidative cleavage. Okay, so in this question number 2, we are combining everything together, the hydrocarbons, but not too difficult. This question, we shall look at this. Okay, we shall look at this. So question number 2, the question say 2-methyl pentate. So 2-methyl pentate. So we can draw the 2-methyl pentane first. So 2-methyl pentane. So pentane 5 carbon. 2-methyl pentane. So the question say react with bromine. So react with bromine in the presence of light. So means that UV, giving you L. Okay, giving you L. So this L adalah monobrominated product. And then the question say dehydrohalogenations of L. So dehydrohalogenation giving you N. Okay, so N as the respective major and minor products. So okay, so form, okay, dehydrogenation of L form M and N. Sorry, so M is missing. Okay, so you can have a look on the question in your book. So M and N. So M and N. So M is the major and N is the minor product. And the question say M undergo oxidative cleavage. So then giving you ketone P and also carboxylic acid Q. Okay, so now, okay, and then the question say N also undergo oxidative cleavage. Then giving you ketone R and carbon dioxide. Okay, and then treatment of acidified water. So N with acidified water. So giving you S. So ask you to suggest the structure of LMNO, LMN, PQ, R, and S. So first, we need to start with, so we have this structure. So we can deduce what is our L. Okay, so shall we look at this first? 2-methyl pentane. So 2-methyl pentane, so to do this type of question, we don't look at it as a 2-methyl pentane. We need to generalize it. This is alkane. 2-methyl pentane, alkane. So alkane undergo what type of reaction? You already learned only one, which is free radical substitutions reaction. So free radical substitutions reaction. Okay, So free radical substitutions reaction. So you can then draw your L. Okay, so draw your L. So this L is the major product. So this L is the major product. So where should the substitutions occur? So remember, I told you already, first we need to class the hydrogen. So this hydrogen, CH3, so means that it's primary. This is H2, so secondary. So this is also secondary. This is primary. H3 is primary and H is tertiary. So substitution on which hydrogen will give you major product? Remember, will be at the tertiary hydrogen. So therefore, your L should be CH3, C, CH3, Br, CH2, CH2, CH3. Okay? And then this is your haloalkane. So L is your haloalkane. So haloalkane undergo dehydrohalogenation. You dah belajar ni, dehydrohalogenation is elimination. In haloalkane, what do you eliminate? The question already tell you, you eliminate hydrogen and halogen. So you eliminate hydrogen and halogen. So halogen you eliminate, hydrogen need to eliminate from the neighbor carbon. Okay, so ada dua neighbor with both has hydrogen. That's why you will get two products, major and a minor. So now shall we draw your M and N? So if eliminate from this carbon, then your double bond will form between first and the second carbon. So it will form between the first and the second carbon. If eliminate from the third carbon punya hydrogen, then your double bond will form between the second and the third carbon. So you will get CH3, C double bond, CH, CH2, CH3. Okay, so which one is the major and which one is the minor product? Remember, we use Says rule to determine it. So circle the carbon-carbon double bond. Yang ni ada dua hydrogen. So therefore, this is di-substituted. So for this one, satu hydrogen. So this is tri-substituted. So tri-substituted is more highly substituted according to Says rule. More highly substituted would be the major product. Therefore, this is your M and this is your N. Okay, so dah jumpa kita punya M and N. Then remember, so now we get alkene. So we don't see it as this is 2-methyl 1-pentene or 2-methyl 2-pentene. No, we don't look at it as the 2-methyl pentene or 1-methyl pentene. No. We look it in a general. Kita tengok ini as alkene. We look at this is alkene and this is alkene M. So alkene undergo how many types of reaction? Dua. Electrophilic addition dengan oxidative cleavage. Okay, and the questions now telling you that N undergo oxidative cleavage. So apa itu oxidative cleavage? So N undergo oxidative cleavage. Remember, oxidative cleavage means that break the carbon-carbon double bond. Break the carbon-carbon double bond. So when this break, you will get two products. So you will get two products. You will get CH3, C. So remember, this is oxidative cleavage. After break the carbon-carbon double bond, so oxidative cleavage means that will give the oxygen. Okay, and then another one here. Okay, so break to half. Break half, so you get, that's why you get two products. So you get CH double bond here, CH2, CH3. The question telling you that you dapat carboxylic acid Q. Carboxylic acid Q. So means that, so this is our ketone. So means that this is definitely ketone P. So means that this must be carboxylic Q. Carboxylic acid Q. But here, this is H. This is aldehyde. So means that oxidative cleavage ini kena menggunakan hot acidified KMnO4. Then you cannot stop at aldehyde. It will further oxidize to give you carboxylic acid. Okay, so it will further oxidize to give you carboxylic acid. Okay, so and then our alkene here, M, also react with acidified water to form S. Also form acidified water to form S. So kalau react with acidified water, that is oxidative cleavage or electrophilic addition. So it must be electrophilic addition. Remember, oxidative cleavage, only two reagents, KMnO4, hot acidified condition, and ozone. So this is acidified water, not ozone, not KMnO4. So it must be electrophilic addition. So kalau electrophilic addition, so the N, carbon-carbon double bond in the N must break, become single bond. So electrophilic addition, so addition, carbon-carbon double bond, break, become single bond. Okay, so now our electrophile is water. So it's water. Remember, addition mengikut Markovnikov's rule. Markovnikov kata apa? Hydrogen need to go to the carbon that has more hydrogen. So this is the carbon-carbon double bond. Can you see that the third carbon here has one hydrogen? Second carbon tak ada. So the third carbon mempunyai lebih banyak hydrogen. That's why the hydrogen of the water must go to the third carbon. And the OH will go to the second carbon. So this is your S. Then now we move on to look at the oxidative cleavage of N. So look at our N. N is also alkene. Oxidative cleavage, break the carbon-carbon double bond. So when break the carbon-carbon double bond, you will get 2. So C double bond O. So CH3, CH2, CH2, CH3. So this is ketone R. And then this side, this is terminal carbon-carbon double bond. So if terminal carbon-carbon double bond, again, this one, the question say giving you carbon dioxide. So means that this carbon will be further oxidized to give you carbon dioxide. Okay? So this is how we get all the product L, M, N, P, Q, R, and S using the alkane and alkene concept that you learned. Okay, again, alkane satu je type of reaction, iaitu the free radical substitutions reaction. Free radical substitutions reaction. Okay, so the major product, okay, will be at the you remember the free radical. So more stable is the free radical, then it will be the major product. So that is alkene. So alkene, two types of reaction. Okay, two types of reaction. So you have seen. So this one is electrophilic addition or oxidative cleavage. So oxidative cleavage hanya boleh guna two reagents sahaja. Hot acidified KMnO4 or ozone. Yang kalau bukan ozone, bukan hot acidified KMnO4, then it must be electrophilic addition. Okay. So now, am I too fast? Class, am I too fast? Am I too fast? Am I too fast? Nobody respond. Okay, a bit. Okay. Okay, good. Nurina Jiha, madam akan lambat sikit. Okay. So, hanya perlu ingat, alkane free radical substitution. Ganti hydrogen dengan halogen. Free radical substitution. Okay. And then alkene oxidative cleavage dengan electrophilic addition. Okay, oxidative cleavage hanya ozon atau hot acidified KMnO4. Kalau tidak nampak dua ini, then it must be electrophilic addition, di mana carbon-carbon double bond menjadi single bond. Okay, so shall we look at question number 11? This is the last question for tonight. So kita practice lagi. Guna the concept of alkane and alkene yang kita belajar, kita try to do this question. Okay, so shall we look at this question? Alkene unsaturated hydrocarbon sebab dia mempunyai carbon-carbon double bond. That's why it is unsaturated hydrocarbons. Okay, it's chemically more reactive than alkane. Ya, betul. Disebabkan oleh carbon double bond, alkene tend to be attacked by electrophile. That's why they are lebih reactive dari alkane. Okay, so the treatment of alkene Y with, okay, so soalan sudah start, alkene Y. So kita tulis dulu alkene Y. React with HBr. Give Z. Okay, and then hydrogenation. Hydrogenation of Y give AA. Okay, and then dia kata reactions of Y lagi. Dia kata react dengan reagent BB. Bagi butanol and ethanoic acid. Okay, so explain the reactivity of Y. So Y kita adalah alkene. So madam tadi baru cerita alkene Y reactive. Okay, kenapa reactive? Disebabkan oleh reactive due to due to presence of carbon-carbon double bond. Okay, which make it susceptible to electrophile, okay, electrophilic attack. So bermaksud dia akan, you boleh tulis saya senang, which make it easy to be attacked by electrophile. Okay, so sebab dia kaya dengan elektron, carbon-carbon double bond, kaya dengan elektron, so dia boleh attack by the electrophile. That is what it means. Okay, so and then ask you to determine the type of reactions involved. So yang ini alkene. This is alkene. Again, alkene, two type of reaction. Oxidative cleavage dengan electrophilic addition. Oxidative cleavage dengan electrophilic addition. So kalau react dengan HBr, so kalau react dengan HBr, ini mesti electrophilic addition. Di mana the carbon-carbon double bond will become single bond. Hydrogenation juga adalah electrophilic addition. Carbon-carbon double bond become single bond. And how about this one? How about this one? Nampak tak? Alkene react with reagent BB bagi kamu butanol, ketone dengan ethanoic acid. So dapat the two product. Bermaksud alkene itu tercabut, terbelah dua. So that must be oxidative cleavage. So this one must be oxidative cleavage. Dia terbelah dua, bagi kamu dua produk. So that is how you determine the type of reactions involved. So sekarang kita boleh try to draw structure Y, Z, AA and identify reagent BB. So what is the reagent BB? So kita tahu this is oxidative cleavage. Okay, so oxidative cleavage hanya ada dua reagent, ozone atau hot acidified KMnO4. Yang ni bagi kita ethanoic acid. So means that this must be the reagent BB must be strong oxidizing agent. Baru akan bagi kita carboxylic acid. So it must be KMnO4, hot acidified KMnO4. So hot kita guna triangle, acidified H+, KMnO4. Okay, or sometimes some of the book they also write it in two steps. So also write it like this. Dia prepare the solution dalam alkaline solutions dulu. In the step number 2 baru acidifiedkan dia. So it's the same thing. Okay? Okay, it's the same thing. So that is your reagent BB. So bagi kamu butanol dengan ethanoic acid. So kalau kita mau tentukan alkene Y, okay, macam mana kita nak tentukan the alkene Y? Mesti dari butanol dengan ethanoic acid. Okay, sebab alkene terlalu banyak, berapa carbon double bond kat mana kita tidak tahu. Okay, but here they already give you the clue. Alkene ini kalau pecah dua akan bagi kamu butanol and also ethanoic acid. So with that kita boleh lukis dulu our butanol. So butanol 4 carbon. Butanol non-ketone. So carbonyl group mesti dekat tengah. It cannot be at the end. Kalau at the end menjadi aldehyde. Okay, so this carbon satu covalent bond, so CH3, so CH2, yang ni 4, so here CH3. So this is our butanol. And then another one is ethanoic acid. Okay, madam tulis nama dia dekat atas. Okay, another one is ethanoic acid. Ethanoic acid 2 carbon. So okay, let me draw this. Okay, ethanoic acid. So this is the ethanoic acid. Yang hasil daripada kita potong the alkene dua melalui oxidative cleavage. So sekarang kita mau sambung balik to get the alkene. So how can we sambung balik to get the alkene? Remember, so here is the carbon-carbon double bond yang pecah. So to get back the alkene, kita buang the oxygen, then sambung balik the carbon-carbon double bond. We buang the oxygen, sambung balik the carbon-carbon double bond. So shall we do that? So rangka carbon ni masih sama. So kita saling je. Okay, so but now kita buang the oxygen and also sambung balik the carbon-carbon double bond untuk dapatkan the alkene. So this is the CH3. Remember, this become OH disebabkan oleh Cat-MnO4 further oxidize the aldehyde. So sekarang kita mau lukis balik the alkene. So here must be the H. So this is your alkene Y. Okay, this is your alkene Y. So sudah dapat alkene Y, then we can deduce what is our Z. Okay, so this is electrophilic addition. Okay, electrophilic addition bermaksud carbon-carbon double bond will become single bond. So how to draw it become single bond? So saling je, saling the rangka dulu. But now double bond becomes single bond. So how to become the single bond? So here and here. Okay, so according to addition, Markovnikov rules. Markovnikov rules kata apa? Hydrogen of the HBr need to go to the carbon yang mempunyai lebih banyak hydrogen. So this is your carbon-carbon double bond. This carbon kosong hydrogen ikat kepada dia. Yang ini satu. So means that this carbon ini has more hydrogen. So hydrogen must go here. Hydrogen of your HBr must go here. And here must be the Br. So this is your Z. Okay, so this is your Z. Then how about your AA? So AA, hydrogenation. Hydrogenation, the electrophile is H2. Is H2, hydrogen. So again, this is electrophilic addition. So kalau electrophilic addition, double bond will become single bond. Tapi rangka masih sama. Kita saling je. CH3, CH2, CH3. So sekarang, the double bond becomes single bond. So single bond. And our electrophile adalah hydrogen. So hydrogen. So setiap hydrogen atom bagi one side. So this is your AA. Okay, so this is your AA. Class, are you all clear? Are you all clear with question number 11? So, are you all clear? Okay. So, if clear, so that's it for tonight. So, could you please say good night to madam? So later on, I will take your attendance based on the good night. So say good night to madam. So if no question, then that's it for today. So say good night to madam, and then I will take your attendance. So say good night to madam. Okay, so okay. 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 Good night, Alif. Okay. So one more. Okay. Good night. Okay. So good night, everyone. Okay. So I end the broadcast now. Bye bye.